Hey there, today we'll be discussing about 2148 problem number. Count elements with strictly smaller and greater elements, and the problem statement is given an integer array nums, return the number of elements that have both a strictly smaller and a strictly greater element appear in nums. So what do you mean by this question? That means, let's say suppose if we start from here, so this index 0 is having a value of 11, and there should be some number which is greater than 11, and there should be some number which is less than this number which is 11. So that can be anywhere in the array, it doesn't matter, but there should be existence of such two numbers. That means, what do we have here? For 11 we see there is a number which is greater than 11, and there is a number which is less than 11 as well. So there will increment the counter by 1. And for 2 we have a number which is greater than 7, that is 11, and there is a number which is smaller than 7 as well, which is 2. So we increment the counter as well, and which is that is the count we are returning here, that is 2. And why not 2 and 15? Since we do not have someone which is smaller than 2, and we do not have someone who is greater than 15, that is why we return 2 as our answer. So the problem statement is pretty intuitive and needs no more explanation, I think. So let's get to the code part. So this is the brute force that I had implemented during the contest. That was the contest number 277. This was the brute force that I used. So the complexity goes pretty much O of n square. That is, I'll be just taking a value from here. I'll make a scan for the entire array and check if there is a value which is greater than this guy. And again I'll make a scan from 0 to n to check if there is someone who is less than this, and if true, then I'll simply increment the counter by 1. So this is the brute force, and we are not interested in the brute force, right? So let's get to the optimal part, which is comment this out. So for the optimal part, we just have to find a number which is the maximum in the array and which is the minimum in the array. And why do we need to do so? Let's get to that. So let me just paste this, or I'll just use the pen right here. So as you can see, we have 11, 7, 2, and 15. And what did I say? I just said that I'll have the maximum as well as the minimum. So if I have the maximum and the minimum, what can we derive from this? I know for every element there has to be some number which is greater than that and some number which is less than that, right? So if I have the maximum and the minimum element, I know if there is some number which is greater than this guy, it will be a maximum number, or it can be any number which is greater than this. So for being on the safe side, I'm just taking the maximum number. So if there exists an answer, this has to be my maximum element, right, for the comparison. So what can we say? So here I have taken 11. So I'll just compare it with this. So is 11 less than 15? Indeed it is. And if there exists a element which is smaller than 11, it can be any number in the array, right? It can be either 7 or it can be 2. So for being in the safe side, I've just taken the smallest possible value in the array. So if this guy has some smaller possible value, this has to be one of them. If not, if let's say suppose if I had 11 as my smallest element, let's not consider anything in the array, let's say I just have a 11 value again, so then this is not possible. So this is what the intuition is: find out the maximum as well as the minimum and just compare it with every index element. That is, now I'll compare. If 11 is greater than 2, indeed it is, so increment the counter by 1, and so on. Just go on finding this, and that will be your code for that. So let me just implement it. So what will I do? I'll do something like int max is equals to uh, max element in nums dot begin. So there's a built-in C++ library function which just find which gives you the maximum element and as well as the minimum element, I'll be implementing the minimum one as well. So I'll just take this, and this will give you the maximum. And if I just do this, it will give me the minimum element. I can simply use two loops as well. It's not a problem, or simply one loop as well. It can be done in one loop also, the maximum and the minimum. I just did this to save some time. After that, what do we need to do? I just need to iterate in the array and check if every number has a maximum and a minimum. So if it is greater than a minimum and it is less than the maximum, so increment the c by 1 or the counter by 1. So int c is equals to 0. So I just took a counter variable which will keep track of how many elements do I have, which is satisfying the condition, and at last return c. So this is what code is. Pretty simple. I'll just run this redefinition of c. I must have declared it again. Yes, I have declared it again. No need to declare it here. Just remove this as well. Okay, this is giving me a correct answer. I'll just run this, and this should also give me the correct answer. And the time complexity for this will be an O of 1, obviously. O of, sorry, n, since we are just doing one pass. So this will take one pass, this will take one pass, and this will take one pass. So it's about O of 3n, which is near about, we can write it to O of n. It can be written as O of n. Yeah. So that is it for this video. Thank you for watching.